Hello and welcome to today's class. My name is Dr. Wanjala Titus. Today we are going to look at the second method of finding point estimators. In the previous class, we were able to look at the method of moment. And today we are going to look at the maximum likelihood estimator. And before we proceed, if you haven't subscribed into this channel, please take a second to subscribe so that in case of new information, you'll be the first one to be notified. Thank you. Now, if you are given a question to find of any distribution, and we said in this unit, you have to know the types of distributions that we were able to look at in the previous classes. We were able to look at binomial distribution, exponential distribution, we have normal distribution, rectangular distribution, and so on. Therefore, once you know those, in the first method of moment, we said you must know the PDF of each distribution. The same applies to this. You must be able to know the distribution of any PDF, the PDF of any distribution. And therefore, let us have a very rough estimation or introductory part on how we can work out the likelihood function. For instance, we say let f of x with parameter theta to be the PDF. Always we must know the PDF to be the PDF of the population, where the PDF of the population where theta is a parameter. Where theta is a parameter. Then we let x1 all the way to xn be a random sample from the population. Random sample from the population. To be a random sample from the population. And we also let the likelihood function to be denoted by L. This one to be the likelihood function. The likelihood function denoted by L. More precisely, we can say now the likelihood function we will now be obtaining as x1 to xn with our parameter theta is defined by this likelihood function. Now, this is now what we'll be doing. Our likelihood function will be x1 all the way to xn theta, then which is equals to the PDF now. We said the PDF to be this one. So it will be f of x1 with parameter. Then we say multiply by f of x2 theta all the way to f of xn with parameter theta. This is how we find the likelihood function. Now you have to note this. This is very important. Now, when we summarize, the whole of this can be represented as the likelihood function is equals to the product. When I write pi, something like pi is now called the product of I heading to 1 all the way to n. Then I multiply by its PDF. Now that is what we call the likelihood function. So this is what we do in every distribution. Now, let us briefly look at this example and we apply the same knowledge that we have used. And this is an exponential distribution. We have been given a question to find the likelihood function. The question says obtain the likelihood estimator for the parameter alpha in the experiment in the exponential population by, we have been given the PDF of f of x alpha is equals to alpha exponential negative alpha x, but it ranges from x greater or equal to 0 elsewhere. Now, we said the likelihood function, we will say the solution. Step 1, we let our x1 to xn to be sample from the population. Sample from the population. Sample from the population. Now, 2, and therefore, if we let in now the likelihood estimator, the likelihood will be L is equals to, now when it comes to here, we take the PDF. I hope you remember what we have been doing. Our PDF is this one now. It will be alpha exponential negative alpha x1. We multiply by alpha exponential negative alpha x2 all the way to alpha exponential negative alpha xn. That is our first step. Now, let us see what can we do. Let us summarize. Our likelihood function will be alpha, because alpha is throughout all the way to n. This alpha is also moving towards n, so it will be power n. Then we come to exponential. Exponential. What about this exponential? The exponential also, this exponential, we see negative alpha is also moving to n. But because it's also moving to n, let us assign any letter k. So let us say it will be negative k alpha. Then we still have x1 to all the way to xn. Now, it will be n x bar. Why have I gotten this? Let me explain. Because I have x1 plus x2, because we are multiplying from the laws of indices, the two functions are multiplying the power we add. So it will be x1 plus x2 plus x3 all the way to xn plus xn, but we will divide by n. So this one is the same as, this one always gives us nx bar. This one means that one. That's why we have had that one. Now, if we proceed, we introduce the ln, the ln. We introduce the ln. So we say ln L is equals to, now it will be n ln alpha, right? Then we subtract because we said k is the same as n. K is equals to n. K is equals to n. Now it will be minus, after we say minus, we just take alpha n x bar. Now, in reaching there, we have always to differentiate. First define the first derivative, dln of L out of, with respect to alpha. D alpha is equals to, this one will give us n out of alpha minus n x bar. That is the derivative of that side. Now, what do? We have to equate this equation to 0. Now, mine will be equals to 0. So, the two will be, I will have this n out of alpha is equals to nx bar. But we all know that n cannot be equal to 0. So if n cannot be equal to 0, so this implies that alpha is equals to 1 out of x bar, where n is not equals to 0. Now, if we reach there, we have to find the second derivative of this equation. Let's see. The second derivative, d squared ln of l out of d alpha squared is equals to, what was it? It was n 1. So this one, we are just creating this one in form of a whole number. It's just coming to be n negative alpha. So if we differentiate this, it's going to give us as negative n alpha negative 2. Are we there? So if we say so, to be negative n out of alpha squared less than 0 when alpha is equals to 1 out of x bar. 1 out of x bar. Now, hence, when we reach here, we say hence, the maximum likelihood estimator for alpha is 1 out of x bar. 1 out of x bar, i.e. we say alpha cap is the same as 1 out of x bar. Hence, that one becomes our likelihood estimator. And before we leave this class, there is the conditions that a likelihood estimator must observe. Condition number 1, those are the conditions that we need to observe. dl out of d theta should be equals to 0, and d squared l out of d theta squared should be less than 0, should be always less than 0. Then this implies that d out of d theta into ln of l should be equals to 0. That's what we mean. And then we say d squared ln of l out of d theta squared should be less than 0.